what we are doing.
Due Wednesday. You have a birthday, Alex? I saw the sign down there. When was it?
Saturday. Oh, happy birthday. Thank you.
All right, let's make sure. Whoops, we're missing Sophia.
That's it over there on that side, okay.
Owen is not here today. Is he gonna be rolling in late? Or
I have no idea. I don't see him until this class today, so.
He what? Therapy or something.
I just need 2 books.
All right. Okay. All right, here we go. We're gonna start talking about, we're gonna spend a little time talking about sequences. So right there, he's got, he's doing a little fill in the blank action. A sequence is a function that maps the whole numbers onto the real numbers. We're gonna talk about what that means in a second. But a function, a sequence is a function, thank you, that maps the wholes onto the reals. So, when we graph a sequence, right, this could be important. When we graph a sequence, we will plot points, but we won't connect them. Even though we will see a definite pattern, we're not going to connect the dots. If we are graphing the sequence, if we are graphing the related function, we're going to talk today about arithmetic and geometric sequences. They are related to linear and exponential functions. When we graph a function, a line, we connect the dots. But if we are graphing the corresponding sequence, it's just the points, we don't connect them. Okay, so example 1. Consider the sequence defined like this. All right, let's let n be 1. What does this say if n is 1? It says a sub 1, that's a subscript, a sub 1, equals 4 minus 3, or 1. This is notation. This means the first term. So the first term is 1. So you've got a sequence of numbers, and the first term is 1. All right, what's the second term? Well, what does your formula say? The second term is 8 minus 3, 5. What is your third term? A sub 3 will be what? 9. Kids, if I'm finding a sub 3, it's 4 times 3 minus 3. Plug it in. Now, what do you notice about these terms? I know I've only done 3 of them, but what do you notice about them? They're going up by 4. Not a coincidence. If I took out that notation and changed it to this notation, what would that be?
Linear function.
That would be a linear function with a slope of 4 by 4. Every new term, every over 1 gives me an up by 4, so that makes perfectly good sense. If I were going to plot this, if n was 1, I got 1, so I would plot that point. And then when n was 2, I got 5, so I would plot that point, and 3, and so on, and that would be a picture of the sequence. Okay? Easy. Now, I didn't find a sub 7, and the notes asked me to, but that's easy. If I'm gonna find a sub 7, I'm just gonna let n be 7. So what is that, 25? I can find any term I want by just plugging in whatever term number it is into my formula. All right, easy. An arithmetic sequence is defined as a sequence where we get from term to term by adding the same number. That's what makes it arithmetic. In a minute, we're going to talk about geometric. Those are different. But arithmetic, we get from term to term by adding the same number. That common, or that same number, the number that we add, is called the common difference. And the common difference equates to the slope of a line. That tells you how much you're changing as you go from term to term. Common difference. Now, there are formulas. You are going to be required to know some formulas. But the exact formulas you're required are fuzzy. There are no ones. You must know this version. Last year, if you talked about this in Algebra 2, and I don't know if you did or not, quite honestly, did you discuss sequences last year? Then you use a formula that looked like that. This is your arithmetic sequence formula. Now, there are other versions of that formula that he has in here, but again, as long as you have a formula to use, it's okay. The version doesn't matter. So, this is the version I like. Let's talk about what all these things mean. A sub 1, anybody want to take a guess or remember what's A sub 1? First term. What do you think D is? Common difference. And N is a term number that you might be looking for. So, for example, if you wanted to find the 58th term, N would be 58. So N is just the number of the term that you are looking for. So that's just a term number. And it's over here too. So for example, if this was all that I had, if I didn't have this formula, if all I had was that right there, and I wanted to find the 58th term, A sub 58, I could do it because my first term is 1, my common difference is 4, and 58 minus 1 is 57. So that formula, if I have a sequence in front of me, this formula will find whatever term I want, okay? Pretty easily. All right. Go ahead in that box where he talks about arithmetic sequences. He has wants you to graph something. Go ahead and see if you can graph the sequence. Remember, it's just going to be some points. And it gets big pretty fast, so I'm only going to graph 3 points, because that's all I have room for. Is that what you got? Don't connect them, that's just it. Example 2. Determine if the sequence could be arithmetic. If yes, identify the common difference. All right, let's look at A. How might you tell if it was arithmetic or not? You think, Kellen?
Do the first three numbers.
So he says do the first three numbers. All right, so let's put in 1. If we put in 1, so the first term, by the way, you don't have to use A, they're using S here for sequence. First term is -2. What's the second term? 1. The third term, okay, are we arithmetic? No, because what does it mean to be arithmetic? It means consecutive terms are going up by the same amount. I love that idea, Kellen, I think that's awesome. I wonder if anybody had a different thought when you looked at this, Alex?
The fact that it's quadratic would make it.
Okay, remember, arithmetic sequences are tied to what kind of function? Linear. As soon as you put an s squared in something, you're no longer linear, are you? So that would be another way you could tell. I love Kellen's idea. I mean, that will always work. If you're arithmetic, your terms are going to be going up by the same amount. His were not, he's not arithmetic. But this one was kind of, there was a clue in there maybe. All right, how about B? Let's do Kellen's trick. What's our first term in B?
4.
4, okay. What's our second term? And our third term? Arithmetic? With a common difference of -2. Let's look at our equation. Let me change the letters a little bit of the equation that we had. What do you think about that? What's that? Is that a line? And what's its slope?
-2.
-2. So yes, that's arithmetic. It's a linear function. Its slope and common difference are -2. Good. Okay, C, no equation, just terms. What do you think about C?
Yeah.
It is indeed arithmetic. What is the common difference? 5. And how about D? No, not arithmetic because we're not going up or down by the same amount. Agreed? You can have all different kinds of sequences. We're only interested right now in arithmetic ones. All right, example 3. We have an arithmetic sequence. And I know that the third term is 8, and the common difference is -3. That's what I've been given. Find an expression for a sub n, and find a sub 12. Those are my 2 tasks. Any thoughts? Well, there's kind of a meat and potatoes way to do it, and then you can get clever and tricky and think and creative and all that. But the meat and potatoes way to do it would be just to stop and think about what's happening. I have an arithmetic sequence, and I know that the third term in the list is 8, and I know that the common difference is -3. So these guys are going down by 3. Okay, does that make sense to you?
Mm-hmm.
Okay, in my formula, I'm going meat and potatoes here. If I use my formula, then I need to know what the first term is. Could I figure that out?
Yes.
I could figure that out by going this way. So this would be 11 and this would be 14.
Yeah.
Would you agree with that? So now I know that the nth term will be the first term plus the common difference times n minus one. Is that okay with everybody? So I'll clean that up. 14 minus 3n plus 3, what is that? Negative 3n plus 17. Is that okay with everybody? Wasn't hard to do that, was it? So now can I use that formula to find the 12th term? Absolutely. Just plug in 12. So what is that? Negative. Is it negative 19?
Yeah.
Meat and potatoes will never ever let you down. Sometimes it's not as quick as maybe some other things you might think of, but if you don't know what to do, go back to this formula every time. And you can do any arithmetic sequence. Okay? Did anyone have a different idea now that we talked about it, a different strategy? Different thought?
Multiply the common difference by the difference of the numbers that you have, like 3 and 12, so you'd multiply 9 by negative 3.
So Declan is saying that I've got the third term and I need the 12th term. So basically, would you agree that I've got to add the common difference 9 times? And since the common difference is negative 3, that would be like adding negative 27. And what's 8 plus negative 27? Negative 19. We okay with that? Now, he found this term, but he still didn't have a formula for a sub n, and that was part of the problem. But absolutely, you can find that 12th term that way. Very good. Very good. All right, 4. We have an arithmetic sequence. We know the second and 6th term. So this notation, remember, a sub 2 means second term. The second term is 7. The 6th term is 9. I need to find an expression for the nth term and then find a sub 24. Thoughts? Get them?
Dude, well, sort of put it into words. The difference is 1/2 because there's 4. The difference between 6 and 2 is 4, and you divide 4 by, or you divide 2, which is the difference between the two numbers, by 4.
He's doing slope. Did you notice that? Remember we already observed that the common difference is like the slope. It's every step you go, it's how your y changes. So he's saying my x's are changing by 4, and my y's are changing by 2. So that makes my common difference 2 fourths or 1/2. Every new term you go, like a sub 3, your y's going to change by 1/2. Your y's going to go up by 1/2. Does that make sense to everybody? Arithmetic or linear. The common difference is the slope. So now he knows his common difference is 1/2. Okay? Alex?
Then would, like to find the original, would you divide, or would you subtract, like, 1/2 times however many, like, a sub 2 is away from a sub 1.
Exactly. So I'm just going to subtract 1/2.
Yeah.
1/2. So 6.5. And then my nth term will be 6.5 plus 1/2 times n minus 1. So 6.5 plus plus 1/2 n minus 0.5. Did you get, 0.5 n plus 6 as your nth term? Is that okay with everybody? And then we want the 24th. What is that? 18th? The 24th term would be 18?
This one.
Yep.
When we write our equation, like if that's part of the issue that we need to write down, do we need to like distribute the 1/2?
Yeah, we want to have the general formula, so that it would be like this. Yeah. That's how you write it. This is called the general formula, and you want it to be cleaned up. If we equate it to your linear function, we want it in slope-intercept form. All right, in example 5. Several terms are shown above. Find an expression for a sub n and use the expression to find a sub 17. All right, go ahead. See if you can figure it out with your partner, doing it from a picture this time. Okay? Give me some ideas here. What did you guys come up with? I need an expression for a sub n. What did you come up with? Declan?
8 minus 2n.
Couldn't hear you. What?
A sub n equals 8 minus 2n.
8 minus 2n. That's what you said, okay? Does everybody get that? No confusion, we're all on target. Perfect. Then what was a sub 17? 8 minus 34, negative 26. So easy. So easy. All right, now we're going on to geometric. Do you remember from last year, what's the difference between arithmetic and geometric sequences? Geometric, we are multiplying by the same number, which can be a fraction, so it's dividing. Whereas arithmetic, we are adding by the same number, could be positive or negative, right? So general formula for geometric. Again, he's got some listed there, use whatever you want. This is the one we typically use. It's an R. Remember, as we go from term to term in the geometric sequence, so an example might be this. This would be a geometric sequence, agreed? The number that we keep multiplying by, in this case 2, is called the common ratio. Ratio. Oh my gosh, I think there's something wrong with it. I forgot how to spell it for a moment. Common ratio, because 6 divided by 3 is 2, and 12 divided by 6, see how it's a ratio? 12 divided by 6, 24 divided by 12. So that is the common ratio. He is fond of using G's here instead of A's. Perfectly okay, the letter you use doesn't matter. So this would mean the first term, and this would mean the nth term. And that's whatever term you're looking for.
Is there a reason they use K's instead of ones?
Because the basic formula works for any value. So I like to have ones, because we normally use ones, but no, you can, if you put 1 in for his K, this is what it says, right?
Yeah.
If you put 8 in, it would say G sub 8 is G sub 1 R to the 8 minus 1. So, yeah, just different versions of the formula. My brain obviously struggles sometimes, so I have to just minimalize it. I got one formula I use, it works all the time, not always the fastest, but it works every time. And that's the one you learn in algebra.
What's this G of 0 one?
G of 0 would mean what? What does that mean, G of 0? That, what's up, man? Your iPad? I don't think so, we didn't use it today. Did you charge it somewhere? Okay, sorry. What would G of 0 mean? Yeah, like the 0th term, which really doesn't make much sense, but in terms of the picture it does, because that would be the y-intercept, right? So it helps graphically to have some kind of notation for that point, but in terms of the sequence, it really doesn't make sense, because it would be the 0th term, literally. All right. Graph this guy. That's definitely geometric, and we're gonna graph it. So what is the first point that you're gonna put on there? When n is 1, you're gonna have what? 4. When n is 2, 3, I'll go one more, 4. So what's happening here? Can you tell what's happening? They're being divided by 2, but I'm not supposed to connect these. So pretend I'm not connecting them. I want you to see the trend though. What's happening there?
Quadratic.
That's not quadratic. That's actually exponential. Remember your BFFs? Remember the exponential looked like this? That's when what you're multiplying by is bigger than 1. So you keep multiplying by 2, they keep getting bigger and bigger and bigger and bigger. Well, here we're doing the opposite of that. We're dividing by 2, so our terms are getting smaller and smaller and smaller.
Why aren't you allowed to connect them? Because if you put in like a fraction for n.
Okay, stop. Go back to the definition of a sequence.
Just for numbers.
Whole numbers. Fractions are allowed. You can't talk about that one, the past term. You can talk about the first term, second term, third term, but that's it. Okay? All right, example 6. For each of the following, determine if it could be geometric. All right, so what do you think about number or letter A? Let's use Kellen's trick. What's the first term?
3.
First term would be 3?
Yeah.
What's the second term?
12.
okay? If it's geometric, then what would the next term have to be?
48.
48. What is the next term when you put in 3?
27.
Okay, is it geometric?
No.
No. And again, guys, huge flashing beacon, it's quadratic. And what did we say geometrics were? Geometrics aren't quadratic, they are exponential. Arithmetic are linear. Geometric are exponential. All right, so what about B now? Looks promising, doesn't it? What's the first term?
4.
4. What's the second term?
8.
If we're geometric, the next one has to be 16. What if you put 3 in?
16.
There we go. Geometric, and the common ratio is 2. This guy right here is the common ratio. Look at your formula. That guy right there is the common ratio. The number that's being raised to the power. That's your common ratio. What in the world? What about C? I don't even know. That's kind of weird. Yeah, no, it's not geometric. How about D?
Yes.
Yeah, and what's the ratio?
Negative 1/2.
Negative 1/2, yep, negative 1/2. Perfect. All right, let's try 7. Same thing we were doing with our arithmetic sequences. Only now we're doing them with geometric, so. We know the first term is 12. We know the ratio is 2. We want to find an expression for g of n, well, that's easy. That will be 12 times 2 to the n minus first. Twelve, 2. And then what's g sub 4? $96. Did you get 96? All right, several terms are shown in the picture. Find an expression for g sub n, and then find g sub n. All right, see what you can come up with. Find an expression for g sub n. What'd you come up with? G sub n is, anybody got it yet? What was your first term? 4. Did you figure out what your ratio was? Can you figure that out from the picture? 1/2. How does that sound? There it is. There's your formula, guys. There it is. I want to show you something. What happens if we put 0 in here? If we put 0 in for that 0th term, what happens here? We have 4 times 1/2 to the negative first. What's 1/2 to the negative first? 2. Is the y-intercept 8? Yeah, so it works. All right, and then you wanted which term, the 10th? What do we get for the 10th term? I don't know. It's going to be very small.
1/128.
Yeah, 1/128, is that what everybody got?
Yeah.
You're right. You are exactly right. Geometric sequences are amazing. We're gonna do a little more practice here in a second, but I love to tell this story. You guys know Daniel Michael, he's a senior, I think, this year. Okay, so his mom, I taught his mom, and she was really, really smart. And I had her in second year algebra back in like the mid-80s. And she came in one day and she said, Mrs. Ford, my dad and I were watching TV, and they said something on TV that can't possibly be right. And I said, okay, immediately I'm getting a little nervous because she's really, really smart. I mean, what is she gonna ask? And she said, my dad thought maybe we could work on it as a class. And I said, okay, what is it? And she said, they said on TV, and some of you may have heard this before, it's remarkable. If you put one checker on the first square of a checkerboard, and then you put 2 on the next square, 4 on the next square, 8 on the next square, and so on. So in other words, a geometric sequence of checkers on the checkerboard. By the time you get to the last square of the board, you'll have enough checkers stacked to reach the nearest star. And she said, Mrs. Ford, the sun is the nearest star, and it's times 10 to the 7th away. I mean, that can't possibly be right. Well, let's think about this for a second. First of all, that's geometric. So this formula should apply. How many squares are on the checkerboard, anybody know? 64. So basically, we want the 64th term of this sequence. According to the formula, that will be 1 times 2 to the 63rd. All right, type it in. And remember that that number is not a distance. That number is actually the number of checkers that you would have piled up. So if we want to convert that to a distance, we got to think about, okay, how many checkers would make an inch? 3. So let's divide that by 3. And now we know how many inches we have. So we can divide that by 12. And then we would know how many feet we have. And then we could divide by 5,280. And now we know how many miles worth of checkers we have. Isn't that amazing? It's 10 to the 13th, by the way, which is to the sun squared almost. Not to the sun and back, but to the sun squared. Isn't that remarkable? Geometric sequences are exponential. And what do we know about exponential growth, you guys? It's really, really big, really, really fast. Amazing story. So now I gotta share one more story. You guys, some of you will learn this, and Miss Price is getting ready to learn this. When you are a first year teacher, life is really hard. Especially when you're young. I was 22, straight out of college, I was gonna change the world, you know? And then they threw me in a class with 36 kids, what we used to call regular, now we call it college prep. They ate me alive. I spent every day crying, it was terrible. Then I had this one kid, and I know him still, I mean, he calls me Sarge to this day, nice kid. But, wrestler, very proud of his physique. Now, I'm a farm girl. I've never lived in a city in my life. All of a sudden, I'm thrown into this urban environment. And I ran my classroom the way my classrooms had been run when I was a student. So if you were bad, back in the farm school, the teacher would make you do something physical, like push-ups. So if you were bad, I would say, that's it, give me 10, or whatever. Well, this kid was so proud of this is a true story, this is true. This kid was so proud of his ability, his physical abilities, that he was deliberately doing stuff. I mean, he was doing push-ups with his feet up on the ledge. He's doing them one-handed. I mean, it became a show-off thing.
Doing trick shots.
So finally, I had it. I said, okay, kid, we're gonna have a meeting with you, the dean, and your mom. And we're gonna come to some kind of agreement here because you are ruining my life and you are ruining the experience for all these other students. So I drew up a contract, and here were the terms of the contract. Because you're not yet 16, you have to come to school. So you will be in school. But when you're in my classroom, I don't care what you do. You can put your head down. I don't care, you sleep. You don't have to do any work, no tests, no homework. You have to physically be present because that's the law. But other than that, you don't have to do a thing. As long as you can fulfill your end of the bargain. So on day 1 of the contract, you're gonna do 1 push-up. On day 2 of the contract, you're gonna do 2. Day 3, you're gonna do 4. Day 4, you're gonna do 8. So it was that sequence right there. Now, I'll never forget, the dean of students looked at me and said, Lisa, are you sure you want to do this? And I said, yes, because what did I know as a math teacher that they didn't know?
By day 30,
He's doing
he
billions.
It
is.
wasn't gonna be very long and he wasn't gonna be able to do that many push-ups, right? On the 10th day of the contract, he was already doing 2 to the 9th push-ups, which is what, I don't even know, but it's a big number. And so it didn't last very long. And I will say, true to his word, we all signed the paper. And he was good after that. As soon as he realized I can't do this anymore, he was good, he came to class, he did what he was supposed to do, and we lived peaceably for the rest of the year. I look back on that now and I think I was a little bit mean, but on the other hand, I had to do something because I wasn't going to survive. Geometric sequences grow remarkably fast. Likewise, they shrink remarkably fast. When you start halving things, making them halves, they get really, really small really, really fast too. All right, turn to the back side of the page that's called goals. Back side. We're going to do check your understanding with your partner. So let's see if we can get this figured out. These are arithmetic. This page is arithmetic. The next page is geometric. So we'll do this arithmetic page first. See if you can get the answers figured out. With your partner, you can talk. if you finish that one, go to the back of the next page and do that check for understanding. That's geometric. In a couple minutes, I want to talk about the first one.
This last one, yes, because.
Just go up by 68.
Why do you really say?
What?
Why do you really say?
It's putting it on the last though. Because that's how she was doing it.
Started written the basic.
She kept simplifying it, so I just did.
All right, anybody get an answer to number one? Find the common difference, that's all you had to do. Anybody find it? 8, tell me how you got 8.
There was 3 terms in between the 8 of the 3rd and 8 of the 6th, and it was negative, or 24.
Exactly. So, I don't know if he knows this or not, but he just did slope. We're going from x equals 3 and y is negative 30. This is like a point. 3 negative 30 and 6 negative 6. So he said the difference in the x's was 3 and the difference in the y's was 24. So the slope is 8. Perfect. All right, how about number 2? Anybody get, what are you doing there? Write a rule for the nth term. What did you come up with for that one?
A sub n equals negative 5n plus 53.
Negative 5n plus 53? That's exactly what I got. Does anybody have a question about that? I kind of did that, I thought about that sort of the same way. This is the slope, right? So I knew the slope. I knew my y's, I knew my x's were 1 to 7, and I just wanted to know what that first y was. That would give me a slope of negative 5. All right, number 3, is it arithmetic? The picture? Yeah, how'd you tell? It's linear. Okay. Arithmetic is linear. Did you write an expression for a sub n? What did you get for that one? A sub n? Good. I was hoping you'd catch that. They changed their scale, so you had to be careful about that, didn't you? Make sure you get your x's and y's correct. Good. And what did you think about number 4? I'm kind of torn about number 4.
Yeah.
What did you think? Alex?
I said the slope is linear because if you're always going at 68 miles an hour, you'll first start at 0, then 68 miles, then 136, then it'll just be linear.
I'm not gonna argue one bit with what he said, but why am I a little bit concerned?
He's like not going faster. He's not going up to like 100 miles an hour. He's like staying at 68. Right?
That's what makes it linear. That's what makes it arithmetic. Every hour, his distance is increasing by exactly 68. That's what I need. If I'm gonna be arithmetic, that's exactly the relationship I need. If that amount I'm going up by is varying, then I'm not arithmetic. I have to be going up by exactly the same amount. All right? So why am I still just a little bit uneasy here?
Because it's like total distance driven, not how much you go up by each.
Doesn't it just?
That would be the same thing, it's going up by 68, yeah. What do you think, Olivia?
He has to accelerate to like, like,
Oh, I know what, yeah, I know what you mean, no, we're assuming he's set the thing and he's going. Yeah, yeah,
Eventually he's gonna run out of gas and have to stop.
you guys. Okay, if I make the assumption that, if I think that this is arithmetic, then what does that mean about my x values? Or in terms of this, my n values? My n values have to be whole numbers, right? So we're looking at, after 1 hour, he's gone 68 miles. After 2 hours, he's gone 136 miles or whatever. In the framework of this problem, could he go half an hour?
It doesn't account for shorter spans.
So therefore, if we think it's arithmetic, then we must have what qualifier? N is a whole number. As long as you're talking about n being whole hours, it's definitely arithmetic. But in terms of the realistic problem, all the things you guys were talking about, running out of gas and accelerating and all that stuff, isn't he gonna drive for an hour and a half? Yeah, and that would not make it an arithmetic sequence. Do you understand that? All that stuff you guys were talking about is going to make it a linear function, not if it accelerates, but a linear function, but not necessarily a sequence. All right, last thing. Oh, we're almost out of time. I've read too many stories. Is number one, we're on the back side of the little red paper. For number one, is this thing arithmetic? I mean, geometric. Right, it's geometric. And so my formula would be 2 times to the n minus 1. All right, let's talk about this one because we haven't done this yet. With geometric, the 4th term is 48, and the 7th term is 384. Find the ratio. Now be careful. We're changing 3 times, right? We have 5th, 6th, 7th term, we're making 3 adjustments here. Every time we make an adjustment, don't we multiply by r? Right? So in getting from here to here, we have to multiply by r 3 times. How do I figure that out? How far is it from here to here? Be careful. What is it? Okay, that would be if I'm subtracting. But remember, I'm not subtracting here, I am multiplying. Wait. What's 384 divided by 48? So getting from here to here, I multiplied by 8, but I did it in 3 increments. So r cubed is 8, so r has to be 2. Remember, in geometric, we are multiplying and dividing, right? Not adding and subtracting. Okay, homework's due Wednesday. What's up?
I know, she's been here the whole time. Yeah, and I never saw you on it. I never figured unless you took it out when you were sitting back there.
Sia, did you bring it with you when you came to class, Matt?
Had a what?
It's on the very